All right, today we're doing Unit 8, Lesson 7, using histograms to answer statistical questions. I can draw a histogram from a table, and I can use a histogram to describe the distribution of data and determine the typical value for the data. So our first question is, here are 4 questions, which one doesn't belong? So remember, this is just like in class, how they, all of them potentially could not belong. You just need to come up with a reason why. So in general, at what age do Alaska residents retire? So that's a variety of people, but that's only one age. Well, I guess not, because it says in general, meaning that, well, people can retire at any age. So variety of answers, variety of people. At what age can Alaskans vote? Well, Alaskans can all vote at 18. So that's no variety. What is the age difference between the youngest and oldest Alaska residents with a full-time job? Well, that's going to be one answer because it says the oldest and the youngest. So that's going to be one answer. Which age group is the largest part of the population? Well, that's got to be one answer too. So I'm going to go with question number 1. So question 1, it's the only statistical question. All the others would provide only one answer. Okay, so then drag and drop. So professional basketball players tend to be taller than professional baseball players. Here are 2 histograms that show the distributions of 50 male professional baseball and basketball players. So basketball players are typically taller, so that means this one has to be the basketball players, and this, oopsie, and this one has to be the baseball players. Wow, that person's really tall. Look at that. Okay, so now professional basketball players tend to be taller. Write 2 or 3 sentences that describe the distribution of the heights of the basketball players. Comment on the center and spread. So I know that I'm just going to type it. The spread of the data is the distance between the 2 ends. So it's about 20 inches because you're going from 90, a little less than 90, and 70. The spread of the data is approximately 20 inches between the players. That would make a big difference because, I mean, that's almost 2 feet. Wow. The center of the data is between 78 and 79 inches. And I'm basing that on because I'm looking at the bars, and when I look, that middle bar that goes between 78 and 80, it the other bars that make up the other halves, so that would be about our center. So that'd be about the middle of our data. Okay, so the spread of the data is approximately 20 inches between the players, and the center of the data is between 78 and 79 inches. So now it says, write 2 or 3 sentences to describe the distribution of the heights of the baseball players. Comment on the center and spread. All right, so if I look at it, it goes from 66 to 80. So that's about 14 inches, right? Yep. The spread of the data is approximately what did I say, 14 inches going from 66 to almost 80 inches. The center of the data, so this is going to take some thinking. It looks like it's going to be between 72 and 73 again, because if you look at how the heights work on the histogram, that's going to be about the halfway point. So the center of the data is between 72 and 73 inches tall. All right, so now I'm going to look at the last slide. It says the two histograms show the number of text messages sent in 1 week by two groups of 100 students. The first histogram summarizes the data from the 6th grade students. The second histogram summarizes the data from the 7th grade students. Well, it looks like there's greater spread in the 6th grade than in the 7th grade, and the center is higher, definitely higher in the 7th grade. So do these two data sets have approximately the same center? So if I'm looking at my centers, I would say the center of this one is somewhere right in here. So that would be about 30. And then if I look at my centers, I would say it's somewhere over here. Oh wait, I read that wrong. It's about 95. And if I look at this one, it's about 95. So are the centers the same? I would say yes. Yes, the centers are both at approximately 95 text messages. Okay, which data has the greater spread? Well, definitely 6th grade, because they go anywhere from 45 to almost 155. So 6th grade, it goes from 45 messages per week to almost 155 messages per week. So they have the greater spread. Overall, which group of students, 6th or 7th graders, sent more text messages? Well, if we look at the data, you can see that the majority of students in the 7th grade sent between 85 and 115 text messages. If you look at this data, if you look at the 6th grade data, while the spread is bigger and you're looking at it, they did between 85 and 95. But that's also where the 7th grade is. So if I was looking at the data, I would say that both groups sent approximately the same number of text messages. Based on their centers. On their centers of the data. Because when you're looking at a center, that tells you where about the middle is. So you want to know, so even though they had a greater spread in 6th grade, when you add it all up, it's probably about the same. So now you're going to go ahead and create histograms. You're going to take a screenshot of your IXL objective and then export that as a PDF. And then I need you to make sure that you take your Unit 7 or your Unit 8 Lesson 7 cool down on Canvas. Let me know if you need any help.